This is round 2 for comparing FastAPI and Golang. I ran the previous benchmark a couple of days ago, and so far I received 13 pull requests with Python improvements. If you're a developer, I would suggest watching the previous benchmark as well and comparing the source code that you can find in the description for both benchmarks and all pull requests. This can help you to avoid the same mistakes I made in the previous benchmark. So anyway, in the first test, we'll measure latency of each request from the client side using P90 percentile. Then we'll measure throughput using requests per second metric, CPU usage of the applications, memory usage, availability or error rate, as well as CPU throttling, since I'll deploy these applications to a production-ready Kubernetes cluster in AWS. In the second test, we'll simulate a real-world use case where your application receives a request. It needs to save it to a relational database as well as use cache to improve performance. For the database, I use Postgres 17.2, and for the cache, I use Memcache. If you're interested, you can watch this comparison between Redis and Memcache. It's not even close. I run all my benchmarks in AWS using different types of EC2 instances. Nowadays, I mostly use Graviton instances, which are IRM based and a little bit cheaper. For Postgres, I used storage optimized I8G large, and for the cache M8G large. Then I use compute optimized instances for the EKS cluster to run Prometheus, Grafana, and other monitoring components, as well as to deploy clients that generate load. And I use M7A large instances for each application, and I run them on their own dedicated VMs using tolerations and affinity. AWS is not cheap, and to support my channel and pay for the infrastructure, I'd like to offer one-on-one sessions and other services. More information in the video description. Alright, let's go ahead and run the first test. This is round 2. I would suggest you to watch the first benchmark using non-optimized Python code and then compare it with this one. In this test, we just return hard-coded objects to the client. In the previous benchmark, I used FastAPI's recommended web server, which is UVcorn by default. I used 2 workers for the first test as well as a sync handler for that endpoint. It performed slightly better in the first benchmark, but then it failed and recovered. In this test, it's a little more stable, but it only reached 11,000 requests per second. It's not a huge difference, but it still has effect on performance. The second test is actually more interesting. At around 11,000 requests per second, it also started to fail due to CPU throttling. Its latency went all the way up and availability dropped. I was expecting better performance with all those optimizations and many pull requests I received so far. You can find all of them in the video description. I'm just going to run it for a few more minutes until Go application starts to fail as well. Go, as always, was able to reach somewhere in 60 to 65,000 requests per second range. It's very decent performance, not the best. Some languages like Rust and Zig can actually reach 100,000 requests per second in the first simple test. But anyway, Go seems more efficient than FastAPI in this test by far. Let me open each graph for the entire test duration. First, we have requests per second. Python reached 11,000 requests per second and Go around 66,000. Next, we have latency, which is, in my opinion, is one of the most important metrics, especially for the client-facing applications, and Go again performed much better. Next, we have CPU usage. FastAPI again very quickly consumed all available CPU. Next, we have availability. Then, memory usage. And finally, CPU throttling. Well, FastAPI didn't perform well in this test, but I'll keep testing different Python frameworks like Starlet, which FastAPI actually uses under the hood, or maybe even creating ASGI Python app directly. So I can build a Python app which is close in terms of performance to Go applications. Now, the second test is where all those improvements went, and it really made a significant difference in real-world use cases. When your application needs to parse the body of the request, insert the record into a relational database, and cache it somewhere like Redis or Memcache. So if you want to improve your Python app, I would suggest comparing both implementations and seeing the real difference in performance on the dashboard. One of the most significant mistakes I made was using blocking Postgres library and SQL model, which is abstraction on top of SQL alchemy. This is the first area for improvements. The second is to use async library for the Memcache as well, along with some other optimizations and refactoring. So in the previous benchmark, FastAPI was only able to reach 750 requests per second. In this test, it performed much better, reaching 2500 requests per second. Compared to the previous benchmark, it's a huge improvement, but it's nowhere close to Go application. In this test, we also measured latency for each database insert operation, the function call to save that piece of data to cache, as well as overall latency of the post request. Python definitely performed much better than the previous implementation, but again, in terms of performance, it's not even close to Go application. Since I received so many PRs and that's the best it could achieve, I think I need to find another Python framework that can come close to the Go application. By the way, in the near future, I'll only test Python frameworks like Django, Flask, and FastAPI. But anyway, let me open each graph for the entire duration. First, we have requests per second graph. FastAPI reached only 2600 requests per second, when Go reached almost 20,000. By the way, in the previous test, Go was limited by the number of connections it could create to Memcache. I just forgot to increase the number of idle connections, and I fixed that in this test. So that's why it could utilize full CPU usage and reach way more requests per second than in the previous benchmark. Next, we have overall latency for the post request. Next, we have latency for the database operations. Then cache latency, CPU usage, next, we have CPU usage for the Postgres and Memcache itself. You can see from the same amount of requests each app makes to the database and cache, you need only a fraction of the resources to run cache. That's why you can greatly improve performance of your applications using caching, and most importantly, reduce the cost of your infrastructure by using fewer resources. Next, we have connection pool to Postgres created and maintained by each app with a limit of 500. And finally, we have memory usage. So I'll keep looking and testing Python frameworks to find actually fast framework. I have other benchmarks that you might find interesting. Thank you for watching, and I'll see you in the next video.